Bismillahirrahmanirrahim. My dear students, I am your mathematics teacher Muhammad Amjad Saeed from Pakistan International School, Taif. Today we will continue our lecture number 16 from chapter number 5, first year mathematics. Here is exercise 5.1 and the related formulas are, first of all, the basic concept is partial fraction. Second one is we have to apply the formulas of square with positive sign. 2ab will have positive sign, and if there is a negative sign here, then 2ab will have negative sign. Square term will always be positive. Similarly, we have the formula a square minus b square that can be written as one time positive, once negative. Similarly, a cube plus b cube, we have a plus b and a square minus ab plus b square. Remember that what is the difference in these two formulas with positive and negative sign? If you have positive sign here in the small bracket, we have positive sign, in the big bracket we have negative with ab, negative central term. And here is minus, then the small bracket will have minus, and opposite sign, that is positive ab will be there. Now we have question number 11. X square plus a square over x square plus b square into x square plus c square into x square plus d square resolved into partial fraction. So, first of all, dear students, we have to convert this variable into the linear form. In case of linear form, you have to substitute let x square is equal to y. Then y plus a square over y plus b square into y plus c square into y plus d square. So in this way we have converted these polynomials in the linear form by having maximum degree of the variable as 1. So let by partial fraction that will be equal to a over y plus b square, capital B over y plus c square, and c over y plus d square. That is your equation number 1. Now multiplying both sides by the LCM. And what is LCM? The denominator of left hand side you can check. They are all different, so they are multiplied to get LCM. Multiplying both sides by LCM, y plus b square into y plus c square into y plus d square. So we are left with y plus a square is equal to a into this y plus b square. This is cancelled out, and we are left with y plus c square into y plus d square. Then plus b into y plus c square is cancelled out with y plus c square, and we have y plus b square into y plus d square. And plus c into y plus d square, this is cancelled out, and you are left with y plus b square into y plus c square. Dear students, whenever you listen to the lecture, you must have your mathematics book with you so that you can have better idea about your questions, about the pattern of the question and pattern of exercise even. So here is equation number 2. We have to find the values of constants capital A, capital B and capital C. For doing that, you will apply putting method by having one bracket will be equal to 0, and then you will find. Putting y plus c square is equal to 0 implies that y is equal to minus c square in equation number 2. So in place of y, I am writing down minus c square plus a square is equal to a into, remember that y plus c square is 0. So apply here 0 and everything will be 0. Then b into y is minus c square plus b square minus c square plus d square and plus c into, remember that again y plus c square here. You have y plus c square is equal to 0. So c into 0, everything will be 0 in this case. So you can write down the proper order. A square minus c square, 0 plus b into b square minus c square, d square minus c square plus 0. Dear students, now you can have capital B is equal to, bring these two brackets on the left hand side, it will come in the denominator. You will have a square minus c square over b square minus c square and d square minus c square. So this is the value of capital B. Here I can write down in this way, a square minus c square over b square minus c square and d square minus c square. After that, put in y plus b square is equal to 0, and here it will be y is equal to minus b square in your equation number 2. Now we will apply these values again in equation number 2. So we have, instead of y, I am writing down minus b square. Minus b square plus a square is equal to a into, remember that here is y plus b square, here is y plus b square, so b and c will be 0. And you will apply the values of y here in first with a, minus b square plus c square minus b square plus d square. Remember that b and c, they are zeros. I have written directly. So we can write down a square minus b square, bring it down and write down in the proper shape, positive term first, c square minus b square into d square minus b square. This is your value of a. This is value of a. A square minus b square, c square minus b square into d square minus b square. That was value of a. After that, using y plus d square is equal to 0 and y is equal to minus d square in equation number 2. Remember that wherever you will have y plus d square, that will be 0. Here a will be 0 and here y plus d square. Here is 0. So we are left with c. And here we will apply that minus d square plus a square is equal to, first term is 0 because y plus d square involves here and this is y plus d square is 0. Applying 0, then everything will be 0. So here is y plus d square also 0 plus c into value of y is minus d square plus b square minus d square plus c square. Now dear students, we will have a square minus b square. You can bring these terms to the left hand side. Remember, positive term will be written first and negative in the second position. B square minus d square into c square minus d square. Now we have found all the constants ABC values. So for the partial fraction now, using values of A, B, C in equation number 1. Values of A, B, C in equation number 1. I am writing down the value of A. What about the value of A? A is a square minus b square over c square minus b square into d square minus b square. Then after that we will write down the value of b. Value of b is a square minus c square divided by b square minus c square and d square minus c square. Now the value of y is value of c, a square minus d square divided by b square minus d square and c square minus d square. After that, we will write down the proper order. We will bring this denominator to the denominator here, a square minus b square over c square minus b square, d square minus b square and y plus b square. That was your first term. Here is the second fraction is a square minus c square over b square minus c square, d square minus c square and y plus c square. And after that, a square minus d square, last fraction, b square minus d square, c square minus d square and y plus d square. Dear students, your question was in terms of x. Here you got the answer in terms of y here. So by backward substitution you will apply x square in place of y. X square in place of y. Now I can write down here y is replaced by x square. Y is replaced by x square. Now this is your final solution. That's your answer. I hope that you understood this question. With this question we have finished our exercise 5.1, and remember that its title was reducible non-repeated linear factors. Exercise 5.1, its title was, its case was, that was your first case in first exercise, reducible non-repeated linear factors. And here, exercise 5.2, its title is reducible repeated linear factors. Reducible repeated linear factors. Remember that in case of linear factor, you will have the maximum degree of variable will be 1. And repeated mean you will have 2 times, 3 times repetition of the same number. For example, this is linear and repeated mean x square, x cube, like that. You will have, suppose, x minus 1. This is linear. But if we write down here x minus 1 square, x minus 1 power 3, then that is known as repeated. Repeated means x minus 1, x minus 1, x minus 1. That is repeated 3 times. So that will be the case in your exercise 5.2. Exercise 5.2. Resolve into partial fraction. resolve into partial fraction, you have 2x square minus 3x plus 4, question number 1. 2x square minus 3x plus 4 over x minus 1 whole cube. Dear students, in this case, when you are having the repeated factors, then for every factor, for every x, you will have one constant. It means that if x minus 1 is repeated by 3 times, then it means that for every x, we have one constant. That power is 3, then we have 3 constants. Let by partial fraction. Suppose I am writing down, let by partial fraction, this will be a over x minus 1 plus b over x minus 1 square plus c over x minus 1 cube. Dear students, you have seen these questions in 10th class, chapter number 4. That is the repeated factor. For one power we have one constant, second power we have second constant, third power we have third constant. So we have to find the values of a, b, c. Multiplying both sides by LCM. Multiplying both sides by LCM. What about LCM? X minus 1 cube. That one. That is the highest. So when it is multiplied, we will get 2x square minus 3x plus 4 is equal to a into x minus 1. This x minus 1 power is cancelled out. We are left with x power minus 2. X minus 1 whole square. And b, when it is multiplied by this one, 2 powers are cancelled with 2 powers and only 1 power left. X minus 1 left. And then x minus 1 cube, they are cancelled out. We are left with c. That is your equation number 2. Putting x minus 1 is equal to 0 implies that x is equal to 1 in equation number 2. Remember that 2 into 1 square minus 3 into 1 plus 4 a into 0 square x minus 1, that is 0, and plus b into 0 and plus c. So we are left with 2 minus 3 plus 4, that will be 0 plus c, and here c is equal to 4 plus 2 is 6 minus 3 is 3. So you have c is equal to 3. This is our one constant. C is equal to 3. After that, there was only one bracket. It was written as 0. So dear students, with this method, by putting method, we have found only one constant c, and other 2 constants will be found with the help of comparison method. Again I am repeating, when putting method failed and you are not having any type of variable or bracket which is to be written as equal to 0, then you will apply the second pattern, second method, which will be inshallah used up to your last exercise. That I say this is known as comparison method. In case of comparison method, you will check this question, and I hope that you will understand easily. 2x square minus 3x plus 4 is equal to a into x square minus 2x plus 1. Open up the square formula, open up the brackets, bx minus b plus c. That was from equation 2. That was from equation number 2. After that, 2x square minus 3x plus 4 is equal to ax square minus 2ax plus a plus bx minus b plus c. Now dear students, you will write down the like terms side by side. Like terms side by side so that you will have comparison. You can equate the two sides of equation. 2x square minus 3x plus 4 is equal to ax square plus, remember that two terms with x here are there. Here are there. So you can write down minus 2a from here and b from the second one and take x common. I have taken x common from here, plus sign, and if there is a negative sign, write down the bracket and write down negative sign inside the bracket. That is minus 2a plus b into x, and then constants plus a minus b plus c. Now, dear students, you can check. Now we can compare. By comparing coefficients of x square, x and constants. What is the coefficient of x square? A. What is the coefficient of x square on the left hand side? That is 2. So a is equal to 2. Coefficient of x square. This is the coefficient of x square. A. Here is the coefficient of x square is 2. So a is equal to 2. Comparing. Then coefficient of x is minus 2a plus b is equal to, what is the coefficient of x here? That is minus 3. Minus 3. And after that, a minus b plus c is equal to 4. Constant and constant, they are compared. A minus b plus c is equal to 4. Here you will have, put a value of a here. What will be? Using a in equation number, you can say this is, suppose this is 3, this is 4 and this is 5. Using a in equation number 3, or rather equation number 4, not 3. Using a in equation number 4, minus 2 into 2 plus b is equal to minus 3. B is equal to minus 3, that was minus 4, it is shifted on the other side, plus 4, and b is equal to 1. Dear students, now you will apply the value of a and b in equation number 5 to find c. And you can check, you have already found c is equal to 3. By putting method, you have found this value. But you can confirm, okay, you can confirm it whether we are getting this 3 or not. So put in a is equal to 2 here, and b is equal to minus 1, and plus c is equal to 4. This is 1, and 1 is shifted on the other side, c is equal to 3. So you can check c is equal to 3. So dear students, we have found the values of constants a, b, c. In equation number 1, we are using that to find your final answer. Using values of a, b and c in equation number 1, we have a is equal to 2 over x minus 1 and plus b is 1 over x minus 1 square and plus c is 3 over x minus 1 cube. That is your partial fraction. That's your answer. I hope that you got the better idea from your question number 1, exercise 5.2. So in this way, you can have the other parts. I'm going to mention that you can use this question number 1 for solving the other parts. This is repeated linear factors. And dear students, in case of question number 2, I think you can do exactly in the same way, just like question number 1. I hope that you can complete your question number 2. With the help of that, you will have your second type, reducible repeated linear factors. Reducible means square, power 3, power 2 can be shifted into power 1 of x or variable. Repeated means whole power not will be equal to 1, whole power, bracket power will have 2, 3, 4 powers like that. And linear means the variable value power will be equal to 1. In this case, you can have better idea about your question number 2. I hope that inshallah you will do it. Okay, inshallah we will continue our next lecture. Okay, Allah Hafiz and Assalamu alaikum wa rahmatullahi wa barakatuh.